Now we are going to start with a topic that is the atomic spectra. As you all know now that we have electromagnetic radiations which have different wavelength and different frequency. So actually we can separate those electromagnetic radiations from each other. And the separating of those electromagnetic radiations, the technique which is used, that is called as spectroscopy. So that means the electromagnetic radiations can be separated from each other, and the technique is called as spectroscopy. So let us see that what kind of instruments we make use of. So the instrument that we use is called as spectroscope or spectrograph. Instead of it, you can also say that it is called as spectrometer, because there is hardly a difference in the two. I am going to tell you that what actually is the difference. Otherwise, the general name what you can call is the spectrometer also. So what does it consist of? It consists of a prism, obviously a source, because we need a source of light, obviously a source of light from where the radiations is actually being emitted, the prism, right, and we need a screen also, where we can get the pattern of the radiation separated from each other, right. So now when you are using a telescope to analyze it, then the instrument, this spectrometer is transformed into a spectroscope, and when you are making use of a photographic plate, then it is called as spectrograph. So you can actually make out that it is requiring a source of light, the prism, the screen also, but what instrument actually you are used to analyze it, that is making the spectrometer as spectroscope or spectrograph. So this is the technique and this is the instrument which is being used. Now when we analyze the atomic spectra, that means the radiations which are emitted from the atom, we see that atomic spectra is of two types. One is the emission, other is the absorption. As you can easily make out from the names that emission means emit, right. So that means here we are going to study or we are going to analyze the emitted light. We are going to analyze the emitted light, that means light which is emitted from any atom. And second is the absorption. So obviously we are here, the absorption is going to take place and we are going to analyze the transmitted light. That means after absorption, whatever light comes out, whatever light remains, you can say whatever radiations remain, we are going to analyze that. So in emission we are going to study about the emitted light, and in absorption we are going to study about the transmitted light. That means after absorption whatever is left, we are going to study that. So starting with the first type, that is the emission spectra. So as I told you that in emission spectra we analyze the emitted light, right. So can you tell me that under what conditions the light is emitted by an atom? Obviously the two conditions. First, it should be a or you can say it should be itself a source, that means it should have its own light. This can be one option. And second is that when we heat it or when we pass an electric current through it, then it emits a light, right. So you need to remember that under what conditions the atom emit light. So under two conditions, one is that when it is itself a source of light, like we have sun, right. Or secondly, when we heat if we heat a sample of an atom, or when we pass electric discharge, then the light which is emitted we can analyze that, right. So please remember this, because whenever you will get a question, you need to write that from where the light is being emitted, right. So you should know about these two conditions. So obviously again in emission spectra we are going to analyze the emitted light. So depending upon that whether the light is you can say the source has its own light, or we are passing any current or heat and then it is emitting light. So depending upon that, emission spectra is classified into two subcategories. One is the continuous, other is the discontinuous. Continuous spectra you all have seen in daily routine. As you all have seen rainbow, rainbow is actually an example of continuous spectra. So just look here that actually what happens in continuous spectra. So continuous spectra is observed when the object has its own light. So the object is continuously emitting its own light, and we are going to analyze that emitted light. So let us analyze it. I am just going to explain you that how it occurs. Let's say this is sun, right? Sun is emitting its own light. So let's say the light is coming like this. I'm going to trace only one ray of light because I cannot mess it up, right? So I'm going to take example of only one radiation which is coming. So this is the light which is coming. I have a slit here to get a proper beam of light. I have a prism here. As you know that in spectrometer, as I told you, we make use of prism. That is the essential condition. So here we have the screen. This is again I told you that we need in case of spectra. So see, when the light falls on the prism, it gets dispersed. You know that what is dispersion? It is splitting of light into 7 colors. You know that, you have studied in lower classes as well. So when the light is made to pass, there is a slit to obtain a fine beam. When it strikes the prism, it split into the dispersion occur, you can say. So it splits into its components, and this is what we obtain on the screen, right? So this is how you can say the spectrum occur. So here what we see is, you know that whenever the sunlight, you can say, you know that we'll discuss that phenomena also, it belongs to physics, but still we'll study that how the rainbow is formed. But you know that, as I told you, that rainbow is an example of continuous spectra. What do you observe in that? You observe that you have different colors, 7 colors, and there is not any demarcated, you can say, line which demarcates one color from the other color. Like we have, like in the rainbow we have different colors. So when the blue ends, the other color just starts, right? So that means when earlier the color is light, then it becomes bright, then it again lightens, and the other color starts. Means the one color merges into another color, you can say that. So this kind of spectra where you see that one color merges into another color, there is no marked line where you can say that this color ranges only till this place and it doesn't extend to this region. So that kind of spectra where one color merges into another color, that is called as continuous spectra. So when you are going to get a question based on this continuous spectra, you are going to write in it that continuous spectra is actually this thing obtained when the source of light, you can say the source has its own light. So when that source, light of that source, or you can say emitted light, is passed through a prism, it undergoes a phenomena of dispersion and you obtain band of colors on the screen. And what you observe actually in that, what we are looking actually here is that we see that one color merges into another color. There is no, you can say, separation between different colors. There is merging of color. So that is called as continuous spectra. And then you are going to draw this figure also, as I showed you that how the sunlight is emitting, how I made to pass through a slit, how it undergoes a dispersion, and what radiations you are getting on the screen. So this is about the continuous spectra. Now coming to the second part, that is the discontinuous emission spectra. So discontinuous, as the name suggests, see, in continuous, as I told you, one color merges into another. Just keep this point in mind, right? So it is continuous, that means you don't see any demarcated boundary, there is no stoppage, everything is in just continuous manner. Now, when I say discontinuous, this must be striking directly in your mind that discontinuous means we'll be having something where we'll have a certain stop and then we'll have a certain start, right? This is what we call a discontinuous. So, where we observe this discontinuous. Here also we are going to study about the emitted light, but the light is being emitted only when you heat that substance or when you pass an electric discharge. So suppose I take a sample of sodium, let's take a sample of sodium. Suppose I have a sample of sodium, and what I am going to do is I am going to heat it. Let's say I am heating it. So when I heat it, it emits the light, right? So this light is being emitted, again I have a slit, again I have a prism, right? And again the same thing is happening, that means dispersion is taking place. dispersion is, let's have a screen like this, right? Dispersion is taking place, and what do we observe actually? We observe that in this case everything is dark, but we have bright lines occurring in a definite region corresponding to wavelength 5890 Armstrong and 5896 Armstrong. This you did know. This you not need to remember these wavelength, because these bright lines occur in a different region corresponding to different wavelength depending upon that what sample you have taken. Like if you take a sodium sample, then you are heating it, and then the dispersion is occurring, and then you are studying the radiations which is being emitted. So then you get these bright bands. You can call it as, because everything is dark, so you can call these bright bands. They are occurring at wavelength corresponding to 5890 Armstrong and 5896 Armstrong. So actually if you will take something other than sodium, then obviously again when you will heat it, there will be certain radiations, there will be radiations, again the bright lines will occur on this screen, but those bright lines will have a different wavelength. So that just depend or vary from substance to substance, that what substance you are taking and what substance is actually taken into observation. But it does not depend that whether you are heating it or you are passing current, that hardly makes a difference. Suppose I take a sodium, I heat it or I pass an electric discharge, whenever the emitted light is being analyzed, the bright lines appear only at 5890 Armstrong and 5896 Armstrong, right. So we can actually say that these are fingerprints of atom, because as I told you that whenever we will be taking sodium, any time you take sodium, whether here or America or to any other place, morning or evening, this is going to happen in the same way, right. So we can say that actually these are the fingerprints of atom, because each atom is going to emit a radiation on being heated or passing current corresponding to the certain definite wavelength. So this is what is it, I think you got it. So this is all about the emission spectra, got it. So I am just making a quick recap. Emission spectra, we are going to study about the emitted light. Two types: continuous, when the object has its own light; discontinuous, when it is being heated or electric current is passed, then it is emitting light. In both the case, we are passing through a prism. In both the case, dispersion is taking place. The difference here lies only in this case, that here one color merges into another, and here you can see a discontinuous spectra. As I told you, bright lines in the dark region. So this is, or you can say bright and dark bands. So this is called as the discontinuous spectra, which is you can say subdivision of emission spectra. Now moving on to the main category of another spectra, that is the absorption. So as I told you that in absorption spectra, we are going to pass the radiation through a certain sample, and then the radiations which are you can say after absorption, whatever the radiation is left, that is called as transmitted light. What we call it as? We call it as transmitted light. So I am going to pass a radiation. Let's say that it is going to, suppose let's take a sample. Suppose I have this solution, right. What I am going to do is, I am going to pass the radiations. Let's say these radiation is a combination of X, Y, Z radiation. So I say that whenever these radiations are passed, this solution is going to absorb X radiation. Let's say it is going to absorb X. So that means the light which moves out is lacking in X radiation, because X is already being absorbed by it. So it has only Y and Z. So when this is called transmitted light, right. So when this is being passed through a prism and it is analyzed, then what do we get? We get actually it is all bright, all the radiations are there, but it is lacking in a particular radiation of particular wavelength. Like in this case, it has absorbed X. So obviously the dark band will appear in the region of the X corresponding to the definite wavelength. I think you got it. So if I take a sodium sample, so let's say we take a sodium salt solution, sodium chloride solution, right. So we know that sodium absorb radiations of wavelength 5890 and 5896, because when we are heating it, it is emitting these radiations only. So obviously this is a matter to think that when the light is passed, it is absorbing these radiations only, right? So when the radiations is being passed, it is absorbing radiation corresponding to 5890 and 5896 Armstrong. So whatever light is transmitted, it is lacking in the radiation corresponding to wavelength 5890 and 5896 Armstrong, right? So obviously what we'll have the whole range of light, but there the 5890 and the 5896 Armstrong will be absent. So there what will be there? There will be only a dark band. So that means in this case we are going to obtain dark bands in a bright region. So whatever light, whatever you can say radiation of definite wavelength is being absorbed, there what we'll see, there will occur a dark band. So when we talk about absorption spectra, it is totally discontinuous in all conditions. It is never continuous. So we can actually say that these atomic spectra are the fingerprints of atom. As you have seen that when we are heating sodium, it is emitting light corresponding to this wavelength. And when I took a sodium salt solution and I passed the light, it absorbed the radiation corresponding to these wavelengths only. That is why when I heated it, it emits the radiation which it has already absorbed. I think you got it, that what actually is the spectra. This is very important, right? So we will be discussing the hydrogen spectra also, because you get a question based on that also. But for the timing, what you do is just make yourself familiar with the emission and the absorption spectra first, because once you need to be you can thorough with these two spectra. Actually they are just opposite to each other, you can say, because whatever light is being absorbed, that is only emitted here, right? The difference lies only with this, because continuous is the one where the object has its own light, or you can say it is itself a source of light. And in this case you get a continuous spectra, one color merges into another color. So this is all about the atomic spectra, but it's not the spectra is not over. We are going to study about the hydrogen spectra also and many more phenomena which are related to it.